Welcome sa part 3 ng ating discussion video lecture about sa area moment method. Okay, so meron tayo ritong cantilever beam with a concentrated load P located a distance from the fixed support, okay, of length L. Assuming EI equals constant, so ang aim natin dito is to determine yung slope and deflection doon sa free end. So in this case, it is labeled as point C. So we're going to determine theta C and delta C. Okay, so we have here our moment diagram. Actually, yun talaga yung conventional moment diagram niya. Okay, so in this case, madali lang naman kunin yung area niya. That is 1/2 base times height, 1/2 times negative PA times A, kasi nga A ito. Okay, so pagdating dito, okay, as we all know, dahil nga fixed support ito, kung gagawa tayo ng tangent line dito, it will be a horizontal line. Okay, nakalabel na yan dyan. If you go through point C, okay, itong deflected shape nyo dun sa elastic curve, at gagawa tayo ng tangent line, okay, it will intersect the tangent line drawn from point A. So magtatama yan dito. And as we all know, okay, this is theta AC because this is an angle, okay, formed by tangent lines drawn from point A and from point C. So dahil clockwise siya from the left tangent, kaya ang sign niya ay negative. So nasa ano naman natin yan? Nasa part 1 ng ating discussion. Okay, dun sa part 1 natin ng area moment method sa derivation. Okay, in the same manner, okay, we have a tangent line here sa taas, and then yung point of consideration natin, let's say this is C prime, okay, nasa baba ng tangent line. So that's why this is a negative deviation. Specifically, this is negative deviation TCA, because this is the deviation of point C relative to the tangent line drawn at point A. Negative nga lang kasi nga nasa baba yung point sa elastic curve as per our sign convention is concerned. And actually, ito yung deflection sa point C. So as we all know, or as we see here, negative TCA is equal to delta C. And kung ito yung negative theta AC, actually ito din yung, wait lang ito rin yung theta C. Okay, so proceed tayo sa pagkuha ng area. Okay, kasi kailangan natin yon pagkuha ng slope tsaka ng deflection. So we have here our solution. Okay, so meron tayong theta AC sa taas. So we have EI theta AC is equal to what? Area between A and C. Okay, so yun yung concerned na area doon sa taas. Ito na 1/2 times negative PA times A. So ito yung nakikita natin dito. Okay, so theta AC is equal to negative PA squared over 2EI. Okay, so therefore, mabilis lang naman to. Theta C is equal to what? Okay, negative theta AC. Okay, balik tayo rito, no? Ito yun. So equal yung dalawang to, no? Okay, so theta C is equal to what? PA squared over 2EI. Kasi ini-negate natin tong negative na to. Kaya naging positive siya rito. Okay. Bakit naging positive? Kasi tama yung assumption ng direction. Okay. Now, for the deflection, okay, so we have what? AI TCA is equal to what? The area of the moment diagram between A and C times the distance of the centroid from point C. So, nasan yun? Okay, ito yung kailangan natin. Balik tayo rito. So, ito yung centroid niya. It is distance A over 3 from the base. Ito yon. Pero hindi yan yung kailangan natin kasi point A ito. Ang kailangan natin from point C. Okay, so we have what? Kung L ito at A over 3 ito. So, we have L minus A over 3. So, napakahalaga kasi ng formula na to sa ating mga susunod pa na discussion or susunod na examples. Okay, so we have what? 1/2 times negative PA times A, yun yung area kanina, times the quantity L minus A over 3. So, pagsamahin natin, ito yung kanina, negative PA square over 2 times this quantity. So, performing algebra, magiging 3L minus A all over 3 ito. Ito yun. So, 3 times 2 will become 6. So, EITCA is equal to what? Negative PA square times the quantity 3L minus A over 6. So, TCA is equal to what? Negative PA squared times the quantity 3L minus A over 6EI. Therefore, we have delta C is equal to what? Negative TCA as discussed a while ago is equal to what? PA squared times 3L minus A over 6EI. So, sa mga nagre-review for board exam, very familiar na sila dito sa dalawang formula na to. Especially ito kasi gamit na gamit yan. Okay? So, i-apply natin itong mga formula na to mamaya dito sa problem na to. Okay, meron tayo ditong example number 2. Okay, so yung mga essential na values nilagay ko na. So, by the way, ito yung sagot. Siningit ko lang kasi yan dyan. Okay. So, we have a trapezoidal loading or varying load linearly increasing from 10 kN per meter to 15 kN per meter dito. Okay, so it is yung 10 kN per meter 2 meter distance from point A and 15 kN per meter is 3 meter distance from point B, making it 5 meters from point A. Okay, so mamaya na natin balikan to. So, nandito sa baba yung conventional niya na moment diagram by parts. Okay. So, by the way, since we are going to take advantage of, okay, dito sa taas, no, yung base ng triangle, usually dun tayo nag-fix, no? So, kailangan natin kunin dito yung reaction. So, madali lang naman yun. Based from statics, makukuha natin yung mga values. So, we have 37.5 kilonewtons and 135 kilonewtons. So, since this is sa part na to na C and C to D, wala naman ng load, therefore, wala ng moment na mapuproduce dito. Therefore, the moment at C should be equal to 0. Check niyan dito. Actually, yung sum ng moment dito sa kaliwa dapat equal sa kanan. Okay, so 187.5 minus 135 minus 45 minus 7.5 is equal to 0. Okay, so pwedeng ganito, patsi-patsiin lang natin, no? Okay, itong 37.5 na to times 5 meters, ito yung 187.5. Okay, ito counterclockwise, so bababa muna rito. Okay, so we have what here? 10 times 3 times 1.5 kasi kalahati ng 3, so yun yung negative 45. And since 15 ito, 10 ito, may matitirang 5 dito. Okay, ito ano, 15 yan. Okay, so we have 1. Okay, 1/2 times 5 times 3 times 1/3 ng 3 na 1. So, nakuha natin dito yung negative 7.5. Just indicate that this is a second degree curve and this is a third degree curve. Bakit, sir? Kasi po, ito ay rectangular, so 0 degree yan. Yung shear diagram, first degree. Yung moment diagram ay second degree. Okay, ito naman, first degree, so plus 2. Third degree yung ano rito, yung curve dito. Okay. So, pinapakuha dito is yung ano, yung delta or theta D tsaka delta D. Assuming EI here is constant. Okay. So, para makuha yung theta D muna, gagawa ulit tayo ng elastic curve dito. Like this. Oops. Oh no. Ganyan. Okay. So, kung gumawa tayo ng tangent line dito, katulad nung kanina, tsaka dito. Okay, ito yung theta, or rather negative theta AD, which is equal to what? Yan yung theta D na hinahanap natin. Okay? So, punta tayo dito. Sa baba. Wait lang. Ayan. So, we have what? Kung titingin tayo rin sa area sa taas, no? Lang. Ayan. So we have what? 1/2 times 5 times 1 is 187.5. Ito yon. Plus 5 times negative 135. Ito yung rectangle. Plus 1/3 times 3 times negative 45. Ito yung area nitong second degree curve na to. Plus 1/4 times 3 times negative 7.5. Ito yung area ng third degree spandrel na to. Okay, so fast forward tayo ron sa sagot. Mabilis lang naman to. You can do it with your calculator. So we have what? Theta AD is equal to what? Negative 2055 over 8 EI. Or in decimal, we have negative 256.875 over EI. Okay, so pwede ba natin gamitin yung formula kanina? Ito. Actually, pwede. Okay, by using integration. Paano po yun, sir? Ngayon, balik tayo rito. Meron tayong kinuhang strip dito. Ang kapal ng strip ay dx. Okay, ito yan, no? So, yung height ng strip na to ay y. But since 10 na ito, yung matitira dito na height ng strip, hindi ito sa taas lang. Ito, no? Ay y minus 10. So, ito yan, no? Y minus 10. Okay. So, by using similar triangles, makakuha natin itong y minus 10 is equal to what? If this is distance x from point A, kasi yung ganun din yung kanina, no? It is represented by A dun sa example 1 kanina. Okay. So, this is x, but since ratio proportion tayo, ito yung kailangan natin, no? Itong portion na to ay x minus 2 lang. Okay? So, balik tayo rito, y minus 10 divided by x minus 2 is equal to what? 5 over 3. So, makukuha natin yung value ng y upon simplification. Y is equal to 20 over 3 plus 5/3 of x. Okay. So, it can be now assumed to be, okay, parang katulad ng equation, ay ng example number 1, na point load na lang to or concentrated load. Pero dahil series of concentrated loads ito, magkakatabi yan. Okay, pag hinati-hati natin yan into smaller pieces, we're going to sum up the effects of this. Kaya gagamit tayo ng integration. Okay, so just remember yung formula natin kanina, ito yun, no? So, pi square over 2ei. So, yung p ay yung y dx. Okay, in which y is in terms of x na nakuha natin kanina, 20 over 3 plus 5/3 of x. Ito yung p. Okay, yung a ay yung x. Ayun, no? Ayun yung a. Dito naman, yun yung x. Okay, so we have what? 20 over 3 plus 5/3 x times x squared. So, ito, no? Nandito. Over 2ei dx. Mula saan? Ano yung magiging limits natin? This is from what? Okay, x equals 2 to 5. Kasi doon nag-start yung pagkakaroon ng load natin. Okay, so, balik kayo ito. Ayan, na. So, we get the same answer actually here. And we just negate it para makuha yon, no? At tulad nito. So, theta d is actually equal to what? Negative theta ad. Ayan, no? So that we will get 256.875 over EI. Okay? So, yan po yung slope sa point D or dun sa free end. Okay. So, dun tayo sa continuation. Dun naman tayo sa deflection. Okay. So, we have what? Balik tayo rito muna, no? So, actually, ito yung TDA or rather negative TDA. Okay, alam natin kung bakit, no? Ito yung delta D. So, paano kukunin yung TDA or EA-TDA? We have what? Area, okay, between A and D times the distance of the centroid from point D. So, just bear in mind that ang kailangan na lang natin kunin dito is yung distance ng centroid ng area na nakuha natin kanina sa slope. Okay, times na lang yung kanilang distance ng centroid from the point D. So, ito yon. So, since 5 ito, 5 meters to, no? So, ito ay 5/3. Kasi, triangle yan. Ito, medyo obvious naman to. This is 2.5 kasi kalahati ng 5. Okay? So, 3 ito. Dahil second degree ito, alam na natin to. 1/4 ng 3.75 yon. And then, dahil third degree ito, yung distance ng center na to, divide 5. So 3 divided by 5, 0.6. So we are just going to add 4 meters dun sa moment arm or yung distance para makuha natin itong mga to. Okay, so ito yung mga area kanina, no? Post a video if you need some time to copy. Okay, so ayan. So lahat ng moment arm kanina, yan na 5/3 plus 4, 2.5 plus 4, 0.75 plus 4, 10.6 plus 4 with the corresponding areas. So ito yung mga yon, yung apat na area. Then ito yung kanilang simplified form, yung mga centroid nila or distance ng centroid nila. So after simplifying, we get what? TDA is equal to what? Negative 15,767 over 8 EI, or in decimals, we have negative 1,970.875 over EI. Okay. So, sir, pwede rin po ba yan sa formulang ginamit natin kanina? So, ito na yung sagot, no? Papatunayan lang natin na pwede ito gamitin. Okay, so if you remember dun sa kanina, we have what? Ito. Okay, so PA squared times 3L minus A over 6EI. Yung P, alam na natin na ito yun, no? Yung Y dx. Okay, so take note that the length of this one, 2 plus 3 plus 4, ay 9 meters. Okay, so pwede rin yung integration. So ito yung P, A squared, 3L minus A, over 6EI. Okay, ayan po yun guys, no? So isa-substitute lang natin. Okay, with the different integral from 2 to 5, syempre hindi pwedeng mabago yan dahil yun pa rin yung limits. Okay, so we get also the same answer. Actually, parehas na parehas yan. Mas madali nga lang to kapag alam mo yung formula para rin sa basic. Okay, na ito, no? Yung kanina, ito. So we conclude that the deflection at the free end, okay, is equal to what? Negative TDA or 1,970.875 over EI. At positive yan. Bakit positive, sir? Kasi po tama yung assumption na nandun siya sa ilalim ng tangent line sa point A or dun sa original niya na position niya. Okay, so for our last example, meron tayo ditong varying moment of inertia. So I have here a basic example lang naman, no? Okay, kasi hindi naman natin muni-discuss lahat yan dito sa video natin. Okay, so we're going to determine the midspan deflection of the beam shown. So we have a 9 meter simply supported beam with a 10 kilonewton load located at the third points. Okay, so pwedeng third points. Okay, middle thirds, pwede rin yon. Okay, so this is actually 33 meters. So by means of statics, alam na natin yan. Take 10 kilonewtons yan. So yung moment of inertia sa gitna, usual, bawa pag ganito. Sir, paano po nagiging posible to? Pwede naglalagay ng cover plate dito. Kaya that's another story. Alam mo, pag steel yung yung cross section, pwede kang maglagay ng cover plate dito to strengthen the midsection kasi usually nga malaki ang moment sa midspan. Kaya minsan kinakailangang lakihan yung moment of inertia sa gitna. Kaya posible itong assembly na ito. Okay. So dito naman sa part na to, no, dahil nga yung moment of inertia dito is twice ng moment of inertia dun sa magkabilang panig. Okay, medyo tricky yung pagkuha ng moment diagram by parts. Actually, pwede naman, pero mas madali kapag ginamit pa rin natin yung conventional na moment diagram. Okay, so we have here the conventional moment diagram. Okay, so balikan lang natin yung shear moment niya, no, or shear diagram niya. So aangat ng 10, bababa ng 10. So sa gitna walang shear, bababa ng 10, akit ng 10. Kaya ganito yung kanyang moment diagram. So okay, so this is 30 kilonewton meter. Okay, So, ito yung conventional moment diagram, pero take note guys, ang dinodrawing talaga natin is yung M over EI diagram. Mula pa nung una, ang dinodrawing talaga natin M over EI diagram. Nagkataon lang na yung EI ay constant, kaya hindi natin siya sinasama doon sa solution. Kasi nga, we can actually factor out EI. Katulad nito, yung sa kanina, naka-factor out siya. Kaya, imbes na TDA equals what? 1 over EI times area between A and D times X barred from point D. Kina-cross multiply na natin yung EI kasi constant siya. But in this case, okay, mahalaga na alam natin kung paano ito. Okay, so ito yung conventional moment diagram, but since dito sa parting ito, okay, twice yung moment diagram, so M over EI. Okay, so assuming ito yung I na gagamitin natin, no, yung I na to. So twice yung I nito, so mahati yung 30 into 2. So 30 divided by 2 I times A, so magiging 15 over EI na lang ito. Okay, so paano naman po yung solution dito? Okay, so since midspan deflection to, mabilis lang to. Pag gumawa tayo ng deflected shape dito, o yung kanyang elastic curve, ito yung tangent line drawn at point A, ito ay TDA. Okay, ito yan po yung TDA. Ito yung midspan deflection, tawagin natin delta M. But since this is TMA, okay, ito yung portion na to, okay, we can use ratio and proportion. Kaya nakuha natin tong equation na to. Okay, delta M plus TMA, okay, divided by kalahati ng 9 na 4.5 plus equals what? TDA over 9. So ito yon. So upon simplification, cross multiplying 4.5 there, so 4.5 divided by 9 is 1/2. So we have TDA over 2 minus TMA. So we just need to get TDA tsaka TMA. So, paano po yun? Okay, mabilis lang naman to guys. Okay, so yung TDA ay equal saan? 1 over EI times area between A and D ng M over EI diagram times the distance of the centered from point D. Okay, so ito madali lang to. Area ng triangle, 1/2 times 30 times 3 over EI. Ito yon. Okay, so yung centroid nyo nandito. Since ito, ilan ba to? Kalahati, 1/3 yan ng 3, na 1. Ito, 3 plus 3, so 6. So 6 plus 1, ito yon, 1 plus 6 na nandito. So this is actually 7. Okay? So ito naman, yung triangle na to, parehas lang sila ng area, 1/2 times 30 over EI times 3. Ito yon. Okay, times, yung distance ng centroid nyo from here ay 1. So, alam na natin yan. Dahil 3 nga ito, 3 minus 1 ay 2. So, ito yon. And then, yung area ng rectangle is 15 over EI times 3. Ito yon. Okay, times sa distance ng centroid niya, halata naman na 4.5 kasi kalahati ng 9. Okay? So, we're going to get here this one. TDA is equal to what? 607.5 over EI. Okay? Next, how about TMA? TMA is equal to what? 1 over EI times the area between A and M only times the distance of the centered from point M. Okay, so paano po yan? Ano yung mga area na concern natin? Ito lang po, mga ma'am at sir, mga future engineers. Ayan na. Ito lang. Yung rectangle, yung triangle na to, times yung rectangle na ito. Iknota, itong rectangle lang na ito, yung kailangan natin. So, we have what? Anong area nito? 1/2 times 30 over EI times 3. Ito yun. Okay? Nasaan yun? Ito. Okay. Multiplied by the moment arm from point M. Take note guys, from point M tayo. So, kung 1 na ito, at nakalahati yung 3 dito, which is 1.5. So, this is 1 plus 1.5. So, ito yon nakalagay rito. It's actually 2.5. Okay? And anong area nito? 15 over EI times 1.5. Okay, so ito yon. Times. Okay. So, anong kalahati ng 1.5? So, 1.5 divided by 2, 0.75. So, ito po yan. So, upon simplification, we will get 129.375 over EI as a value of PMA. And finally, the midspan deflection, actually dahil symmetrical to, no, we take the advantage of symmetry. Pwede rin naman yun. Okay, kaya symmetric din yung moment diagram natin. And eventually, symmetric din yung moment diagram by parts. Okay, so we have 1/2 times TDA na 607.5 over EI minus TMA na nakakakuha lang natin 129.375 over EI. We get this one, 174.375 over EI. And this is the midspan deflection, which is actually the maximum deflection. Okay? So, siguro ito na yung last part ng ating discussion sa area moment method. So, stay tuned for more uploads regarding civil engineering subjects. Okay. So, shout out nga pala. So, nakalimutan kong lecture sa Falcon, si Engineer Henner Rosario. So, pasensya na sir, nakalimutan kitang banggitin dun sa part 2 ng ating video, no? So, okay. So, God bless guys. Stay at home. And God bless to all of you.